Hey guys, we're doing our last section today of chapter 4, 4.9 linear quadratic systems. And again, our mission here is I can solve quadratic linear systems of equations by utilizing various methods. So I'm going to jump right in here to an example, and this is going to be pretty easy for you, I think. But I want to show you, and it'll help you appreciate the algebraic things that are going into this. But I want to show you an example of what I'm talking about here. Remember, a system's always more than one equation. So let's imagine that we have the equations y equals x squared minus 4x plus 5. And we had y equals 2x minus 3. Now remember, with systems, there's several different methods you can go about in solving these. You could graph them. You could do substitution. You could do elimination. All kinds of different ways that you can go about doing systems, matrices, all kinds of different ways that you can go about this. Well, I want to just show you real quickly, and this is usually what my mind goes to again. If I'm given two equations that are both y equals, then I think about substitution if I'm thinking about doing this algebraically. So what I mean by that is this. You notice I've got y equals 2x plus minus 3. Well, I could take that 2x minus 3 because it is equal to y, and I could substitute it in for this y right here. So basically, what we would really have as far as a problem is we would just take these two things and we would set them equal to each other. So if you think about it, you'd have 2x minus 3 equals x squared minus 4x plus 5. And initially you may think, well, that doesn't make a whole lot of sense, and I'm not sure I can make any sense out of that. But if you just think about it, I could subtract this 2x from both sides, like so. And that would give me negative 3 equals x squared minus 6x plus 5. And then I could add 3 to both sides. And now all of a sudden, I've got something that says 0 equals x squared minus 6x plus 8. And so we now see that this is something quadratic that I could solve. And this one's actually pretty easy to solve. You notice I've got a 1 here in the front. So I could look at the factors of 8. That would add together and make negative 6. And so maybe real quickly you could see that, well, if I put x and x, factors of 8, 1 and 8, 2 and 4, and that's basically it, right? Which two could I add together to get a negative 6? Well, that would be a negative 2 and a negative 4. So you can see pretty quickly that if you set those equal to 0, remember what happens here. If I take x minus 2 equals 0, I'm going to be adding 2 to both sides. So it just becomes the opposite of what I have up here. So the same thing's going to happen here. So I'm going to have x equals 4. And I did that to say that, well, you can use algebraic methods to go about this. But notice that all that we figured out is we figured out that x equals 2 and also x equals 4. Well, what do I do with that information? Because remember, my original problem up here, again, x equals 2 and x equals 4. But notice I also have a y value here that I need to try to figure out. Well, what I'm going to have to do now, and you can already begin to see how much work this kind of is I'm going to have to take both of these values for x, and I'm going to have to substitute them into these y values. Well, it makes sense probably to input them into this one because it's a lot easier. So I'm going to take 2 times 2 minus 3. I just substitute the 2 in for the x right here. So that equals 4 minus 3, which simply equals 1, okay? So remember, we're solving for y now. We're taking the values of x and substituting them in so that I can find the values for y. Well, I'm also going to go ahead and take the 4, and I'm going to put it in for the x here as well. So 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 will equal 5. So notice what we're really saying here. We're saying when I put in a 2, I get out a 1. All right, notice how I wrote that. Here's an x and here's a y. I'm also saying that when I put in a 4 as an input, then I get out a 5 as an output. So I want you to notice here for this particular system, because I'm using one equation that's a quadratic and one equation that's a linear, that I actually come up with two different solutions here, okay? So again, I want you to understand that when you're working with systems that are linear and quadratic, you're going to actually have two solutions, not just one. So now let's look at this graphically, because I think this is probably what most of you are going to do anyway. But I just wanted to show you kind of how to do it algebraically in case that ever comes up in college algebra specifically. But again, let's just make sure that these are correct solutions. And I think a picture is kind of worth 1,000 words. It will help you to kind of see what's actually going on. So let's go on to Desmos, one of our favorite calculators now. And let's go ahead and put this problem in. Y equals x squared minus 4x plus 5. And you see there that graphed that line for us, which is a quadratic. Now let's go ahead and put in our next equation, y equals 2x minus 3. And you notice that is linear, which we would expect because it's not being raised to any power. But what I want you to notice about this is notice that this actually has two distinct solutions. There are two places where these two graphs cross. And look at there, we did pretty good with our math work, I think. We end up with a solution of 2, 1, and a solution of 4, 5. So both of those would be correct solutions that we come up with algebraically here, okay? I also want you to think about the fact that there are instances where you will not have two solutions. So let's see what we can do here. Let's take this down just a little bit. So y equals 2x minus 4. And here's what I want you to notice now. Now I only have one specific spot that this is crossing at. So that means if I were comparing these two linear and quadratic equations as a system, then I would only have one solution. So what I'm warning you of is you're not always going to have two solutions. There's going to be times when you may just have one solution. As a matter of fact, there may be times altogether when you don't have any solutions at all. Let's change this y-intercept to y equals 2x minus 5. And notice what happens. These two lines, these two equations of lines, are not crossing at all. That means there's going to be no solution for this particular one because these lines are never going to cross. And so there are no values for x that's going to create a certain value for y. So again, hopefully this makes a little bit of sense to you. It's a lot like what we've already been doing with solving systems way back in chapter 3, I believe. But here we're actually using one equation that's quadratic, which changes it up just a little bit, okay? So again, probably the easiest way to do this is just go ahead and put those two equations in Desmos. And again, look for those places where those two lines cross, if they cross or if they just cross one point. And if you just hover over those points, you can go ahead and click them and it will tell you what those solutions are, okay? It was a pretty easy task today, I think. You have a form that you need to complete that has several of these problems on it. And so again, this is kind of all you have to do is just put it in Desmos, and it should help you greatly to accomplish this task. So if you need extra help, make sure to reach out to me or Miss Wheeler, and we would be glad to accommodate you with that as well. Thanks.